So I'd like to go through this question 5 from 3.2 involving an application of a golf ball being hit. So a golf ball is hit with an initial velocity of 130 feet per second at an angle of inclination of 45 degrees to the horizontal. In physics, it is established that the height h of the golf ball is given by the function h of x is equal to negative 32x squared plus, or divided by 130 squared plus then the x, where x is the horizontal distance that the golf ball has traveled. So we want to complete parts A through G, or actually, I believe it's A through H. So the first question says, determine the height of the golf ball after it has traveled 100 feet. So essentially what they're asking for is, they're asking us to figure out H of 100. So X represents the horizontal distance, and then H of 100 will represent the vertical distance. So what I have to do is substitute 100 into this formula here. Now, since there's several questions involving this formula, I'm going to use the calculator and just put the formula into the calculator. So I'm going to use the y equals button on the calculator, and I'm going to put the function in y1. So since we have a fraction, I'm going to use parentheses here. In parentheses, negative 32 x squared, and then I'm going to divide that by 130 squared, and then close that parenthesis, and then I'm going to add x to that. So that's going to be our formula to determine the height. So what I can do is go to my table, but right now my table is going by 0, 1, 2, 3, 4, so on. But really what I need is like h of 100. So let's change how this counts by. So under table set, I'm going to change my table to count by hundreds. So changing table, I'm going to change to hundreds. So now if I go back to the table, so 0, it didn't go anywhere, but at 100 feet, as it has traveled horizontally 100, it's now going to be 81.065 off the ground. So if I make a little bit of a sketch here for this, so I have like n axes here. So we have the initial start is here. The golf ball is going to be hit kind of at a 45-degree angle, so it's going to be kind of taking off here. And then somewhere along the way, gravity is going to pull it back down, and it's going to come back down. So basically what they're asking for, as the horizontal distance is 100, how far off the ground am I? That's the question. So it's not a bad idea to actually get a graph of this as well. So if we get to a graph, I don't look like the graph that I need. So if I go y equals here, let's see here. Okay. So I think what we need to do is we need to change our window, our viewing window a little bit, see if that makes a difference here. So if I hit window, notice how it's just going from negative 10 to 10. That's too small of a window. So let's say our horizontal distance, and again, if I think about in golf, a lot of golfers can hit a golf ball around 300 yards, which would be around 900 feet. So I'm going to go ahead and just change my X max to be around 1,000. If I do that, I want to count by 100s here. Now the height, Y max, I really don't know how high a ball goes up. Let's just start with, say, 500 feet in the air. If I do that, let's count by hundreds there. See if we get a graph that generates something that's like what we're looking for. Notice how I really didn't need to go so aggressively on my vertical. So window, let's change this to like 250. And then just go by 50 here. And let's see if we graph it again. That looks more like a trajectory of a golf ball that we're needing. So what we're basically saying is this first tick mark is 100. We will know how high off the ground it is. So again, what I can do though is just go to the table, At 100, I'm seeing that it's going to be 81.065. Now, notice how our question says round to the nearest two decimal places. So that's going to be 81.07. So this is going to be 81.07 feet. Now, the next question says, what's the height of the ball after it travels 300 feet? So it's going to be like two tick marks over. So if we look at the graph, so this is like 100, 200, 300. So notice how, based on this, it looks like we're almost at the peak height here around 300. It looks like it's already on its way back down based on the graph. So it's starting to come back down. So if I go back to my table, at 300, we're seeing that it's going to be 129.59. So 129.59 feet for 300 feet. So next thing it says, what is h of 350? Remember, the 350 is horizontal distance. So h of 350 represents the vertical distance. So it looks like I don't have the 350 here. So let me start at 200. Let's start at 200 and count by 50s and go back to the table. So 250, there's the 350 there. So notice that by just manipulating the table a little bit, this kind of helps me out here. So at 350, notice how it looks like we're coming on our way back down. So 118.05 looks like the answer there. So 118.05 feet. So again, if I go back to my graph, so notice how this is 100, 200, 300, 350 be here. So notice how this is about where we would be. And notice how now we're counting by 50s. So this is like 50, 100. Notice how it's going to be a shade over 100. So 118.05 feet. So notice what this basically means is the height of the golf ball has traveled a horizontal distance of 350 is 118.05 feet off the ground. So actually A does match us here. So there's two choices here. What does it mean? Remember, the horizontal distance is the 350. And what we found was how high off the ground it was, the vertical distance of 118.05 feet. Question D says, how far was the ball hit? So basically what they want to know is where I'm at back on the ground. So back on the ground is actually called a zero. So if I go to calculate on my calculator, second calculate, number 2 is called a zero. So left bound means I need to be left of it. So it looks like I'm left. Right bound means I need to be right of that x-axis. So I need to really see that my y value goes below the x-axis because then I'd be to the right of 0. So if I hit enter there and notice how it says now guess. So when y is 0, I'm going to be 528.13 feet off the ground. I'm sorry. My horizontal distance is going to be 528.13 feet. And I'm going to be on the ground. So the ball has traveled 528.13 feet horizontally. Now, another way you could do this instead of doing zeros, you could say graph the line, graph the second equation, y equals 0. Y equals 0 represents the ground. So if I graph this, the x-axis is now going to be determined as the ground. So what I can do is I can find the point of intersection of the way the ball travels and the ground. So if I can find this point of intersection here, that's also going to be my answer. So if I go to second calculate, number 5 is a point of intersection. So first curve, enter, second curve, hit enter, guess, hit enter. It should take me to that point of intersection of where x is 528.25 or 13 feet. So that would give me the same spot. Now here they actually give us a scale to go by. So they want our x's to go from 0 to 600. So if I change my window, I went from 0 to, well, actually, I went to -10. So they want us to go from 0 to 600. They want to match that viewing window. And then they want us to make the y's go 0 to 140. So let's make the x scale go by, they say x scale goes by 100. That looks okay. The y min is going to be this 0. The y max is this 140. And then my y scale, they want us to go by 20s. So if I graph that, it should generate a graph that looks more like what they have. So notice how I graph mirrors more like D. So question F says, using a graphing utility, determine the distance the ball has traveled when the ball is 90 feet off the ground. So to do this, basically what we're saying is our function is this -32x squared over 130 squared plus this x. They want to know when we're 90 feet off the ground. Now, there's two ways of doing this. One way is to graph the horizontal line, y equals 90 as well. So instead of having 0 here, I could put 90. Y equals 90 represents 90 feet off the ground. If I graph that, that's going to be the travel of the ball. Notice that y equals 90 represents how high off the ground I am. So notice how it gets up to 90 feet twice on the way up and on the way down. So if I can find these 2 points of intersection, that's going to tell me how far off the ground I am. So under calculate, if hit the second button, trace, number 5 is intersection, I could find this intersection point over here. So get my arrow close to that, my little, I guess they call it a spider, little blinky thing there. Hit enter again, hit enter a third time, and it'll actually take me to this point of intersection. So the ball's actually traveled 115.07 feet. So 115.07 feet on the way up. And then if I hit that again, this calculate button, it'll help me find the point of intersection. Number 5. So if I get myself over there, hit enter, hit enter, hit enter, it'll take me to this point of intersection. So I'm back at 90, and I'll see how now the ball's traveling 413.05 feet. So there's actually two answers. So 413.05 feet would be the other one. So 115.07 feet on the way up, and the ball's gone 413.05 feet on the way down. So G says create a table. So start the table at 0. So table set, start at 0. They want you to change the table by 25s. So change the table to 25. And to this 25 feet, how far does the ball travel before it reaches the maximum height? And then what is the maximum height? So if I go to the table, I don't need this 90 anymore. So let me get that out of there. Y equals, and we'll clear off the equation number 2. So highlight there, hit clear, and now go back and hit graph. It should just graph our golf ball. So where we got our traveling of our golf ball, but we want to go back to the table. And this is our horizontal distance, and this is our vertical distance. But what we're looking for is where our y is at its maximum height. So I'm looking for, it looks like at 275 feet, it's at a maximum height of 131.8 feet. So to this 25 feet, the ball has traveled 275 feet. And the maximum height would be 129.59. So it's gotten to a maximum height of 129.59 feet. So now it says H says adjust the change the table to determine the distance to within 1 foot. So the ball travels before it reaches its maximum height. So they want us to change our table to the nearest 1 foot. Now, notice how our maximum height's around this 300 area, if you will. So let me go ahead and start my table at 300. And then let's change the table to ones. Now, if I go back to the table, let's see where we get here. So it looks like 300, it's at 129.49, but 301, it's 129.45. So that's going down. Notice that 299 is actually a little higher. 298 is a little higher. 297 is a little higher. Let me go a little bit more. Oh, it's still higher. So it looks like 131s are still higher. So that's I'm going up. 132s. So looks like the 132s is where we are. So if I scroll over here to the 132s, so 132.01, 132.02, 132.03. Notice how there's three of these. So 132.03s is what we're looking at. Now what we're trying to figure out is which one was the biggest value. So if I notice how again I'm under the Y column, by doing so, it takes my decimal out a little bit further. So at 265, it's actually 029. At 264, it's 031. And 263, it's back to 029. So it looks like within a foot, 264 feet is when it's at its maximum height. So how far does the ball travel before it reaches its maximum height? Based on that, we're seeing 264s is actually where it hits the maximum height. It's 264. So the trick to H is you actually have to slide over to the Y column and start studying the Y columns, because if you stay in the X columns, notice how the Y's are harder to discern between. But once you slide over to the Y column, it now displays the Y values further. So then you can kind of see that these three here have the same value, but it looks like the 264 is actually the biggest of all if we're not rounding at that spot, two decimal places. So see if that helps you get through that question 5 there.